Neutralization and titration. Neutralization is the reaction between an acid and a base to get water and salt. It's clear that if you have an acid with pH less than 7 and you want to make it a neutral, you have to add to it a base. But if you add too much base, then you are going to end up with a solution where the hydroxide ions are more than the hydronium ions, and this solution is going to be basic. If you don't add enough amount of the base, you're going to end up with a solution where the hydronium ions are more than the hydroxide ions, and this solution is going to be acidic. So you have to add base till you reach a point where the amount of the hydronium ions is equal to the amount of the hydroxide ions. This point is called the equivalence point. At equivalence point, we get a neutral solution. At equivalence point, the number of moles of hydronium ions is equal to number of moles of hydroxide ions. And we learned earlier that number of moles can be calculated by multiplying the concentration, which is the molarity, by the volume. So we can use this formula at equivalence point. Concentration of hydronium ions multiplied by volume of hydronium ions, it's equal to concentration of hydroxide ions multiplied by volume of hydroxide ions. So whenever we have equivalence point, we can use this formula. Now, titration is a procedure that we use to measure the concentration of unknown solution. We use a device like this. Let me give you an example. Imagine that you have an acid with unknown concentration. So you take a certain volume, 20 milliliter for example, you put them in this conical flask. And then you get a base with a known concentration and you add it to the burette. Burette, it's like a tube graduated with a tap at the bottom. So you open the tap and you keep adding a base to the acid till you reach the equivalence point. At the equivalence point, you close the tap and then you have the concentration of the base with the volume added of the base, and you have the volume of the acid. By applying the formula concentration of hydronium ions multiplied by volume of hydronium ions equal to concentration of hydroxide ions multiplied by volume of hydroxide ions, you can find the concentration of hydronium ions. And from the concentration of hydronium ions, you can find the concentration of the acid. This is how we use titration. But the question is, how we know that we get the equivalence point? Here we have to use an indicator. An indicator is a substance that gives different colors with acids and bases. Since we have different indicators and different colors, I'm going to explain how to use the right indicator with our experiment in another video. So by adding the indicator to the acid, we know at what time we have to stop. At that time, there will be like a sudden change in the color. When you notice a sudden change in the color, you stop adding the base, and then you know that this point is the equivalence point. I will show you a practical example that I did in the lab. I used the titration procedure to calculate the concentration of vinegar. Vinegar is a weak acid. I took 10 milliliters of vinegar. I used a graduated cylinder to measure the 10 milliliters. Some books, they advise you to use a burette to measure that amount. I took the 10 milliliters of the vinegar and I added them to the conical flask or the Erlenmeyer. Then I added few drops of phenolphthalein. It's a colorless indicator that stays colorless with the acid and changes pink with the base. And I wanted to add sodium hydroxide to the burette. But first, I had to wash the burette with sodium hydroxide. As you see, I kept the tap open for the sodium hydroxide to pass through the burette and to wash it. Then I closed the tap and I added the sodium hydroxide in the burette. After I added sodium hydroxide in the burette, I had to calibrate the burette. I have to make the level of the sodium hydroxide reaches the zero at the burette. So I open the tap slightly to make the level of the sodium hydroxide reaches zero. The bottom of the meniscus should be at zero. So now the device is ready. I have the sodium hydroxide with a known concentration is found in the burette, and I have 10 milliliters of the vinegar in the conical flask. I added few drops of phenolphthalein, and now I'm going to keep adding sodium hydroxide till I notice a sudden change in the color. At this point, I stop adding, and then I have the volume added of the sodium hydroxide, and I have the concentration of sodium hydroxide, and I have the volume of the acid. Then I can find the concentration of hydronium ions, and from that I can find the concentration of the vinegar. Let's practice some exercises about neutralization and titration. Like in this exercise, we have a student titrates 20 milliliters of nitric acid solution of unknown concentration with 0.2 molar potassium hydroxide solution. The volume of potassium hydroxide solution needed to reach the equivalence point is 25 milliliters. What's the concentration of nitric acid solution? Here, the question is telling me that we reach the equivalence point. In some questions, you are going to find it as pH equals 7, which is the same. We are going to apply the formula concentration of hydronium multiplied by volume of hydronium. It's equal to concentration of hydroxide multiplied by volume of hydroxide. Here, you have to keep something in your mind that nitric acid, it's a strong acid. So the concentration of the hydronium, it's equal to the concentration of nitric acid. And also, potassium hydroxide is a strong base, which means that the concentration of the base, potassium hydroxide, it's equal to the concentration of OH minus. Then we replace the variables by their values. Concentration of hydronium, it's equal to concentration of hydroxide multiplied by volume of hydroxide ions divided by volume of hydronium. So here we multiply 0.2 by 0.025 divided by 0.02. I converted the volumes to liters. You are going to have the concentration of hydronium ions, it's equal to 0.25 molar, which is equal to the concentration of nitric acid, since nitric acid is a strong acid. Here we had the volume of the base given in the question. But what if we have to find the volume of the base added from a graph like in the following exercise? The graph below shows a titration curve obtained during the titration of a 10 milliliters of hydrochloric acid solution with a 0.5 molar sodium hydroxide. Calculate the concentration of hydrochloric acid. Also here, hydrochloric acid is a strong acid, which means that the concentration of the hydrochloric acid is equal to the concentration of the hydronium ions. And also sodium hydroxide is a strong base, which means that the concentration of the sodium hydroxide is equal to the concentration of the hydroxide ions. At equivalence point, here we find that the pH is equal to 7. From the graph, when the pH is equal to 7, the volume added of the base is equal to 38 milliliters. So we apply the formula concentration of hydronium ions multiplied by volume of hydronium ions equal to concentration of hydroxide ions multiplied by volume of hydroxide ions. Concentration of hydronium ions, it's equal to 0.5 times 0.038 divided by 0.01. I converted the volumes to liters. By the way, if you don't convert them to liters, you are going to get the same answer. And the concentration of hydronium ions is going to be equal to 1.9, which is equal to the concentration of hydrochloric acid. God bless you all, and see you in another video. If you find my videos are useful, subscribe to the channel and hit the bell icon to get notified and watch the new videos. Don't forget to share this video with your friends and write me a comment. Thank you.